Couple of you struggled with some of the homework questions, so I thought I'd make a short video to talk about those. Once again, I would like to repeat that I will try to reply to every email I get within 24 hours. Some of you got replies asking you to look again at something that you had submitted. That means I'm going to regrade the submission if I get it back in a timely manner. This week there were a couple people that did not get the homework submitted, and that's unfortunate. So I'm going to go through just a couple of these here. So question number one was on the power calculations, and many of you struggled over the wind velocity raised to the third power. Notice in the example in the instructions shown here that we had 5.008 v cubed. The fact that the v cubed is right next to the 0.00508 means they are multiplied as shown in this second line. And finally, we cube the 8. 8 times 8 times 8 is 512. When multiplied times the 0.00508, we end up with 2.6 watts per square foot. All right. So everyone got questions 1, 2, and 4 correct, but it was when we got down to question number 5 that we had some problems. And I think it may have been the reason because down here I had the V separated from the 508, and I put the times symbol, a lowercase x, times the EPF. Well, again, up above, when I have a V next to the 508, we're supposed to multiply them together. I'm going to show you how I did that on my calculator. So this is the calculator on my MacBook Pro, 0.00508. This is the function key I used here, right? Your calculator might be different. So I have to multiply this first times the 10 miles an hour, which is raised, there's the caret that raises it, raised to the third power. When I hit equals, that shows me that question number 5 here would be 5.008. Except that's actually the answer for number 1 here. We have to multiply that times the 1.91 times 1.91, and now we have our correct answer of 9.7 watts per square foot of rotor. All right, pretty simple. Notice I could have also, the 10 miles an hour is what got raised to the third power. Well, this calculator has a cubed function. I could take 10 and cube it. 10 times 10 times 10 is 1,000. Or I could use the 10 raised to the third power. I get the same answer. Good enough. I'm going to show you how we did that using the Excel example. So here we are. First I had to bring my data in. Now remember, on page 30 of the book, the textbook, we had this sidebar that showed that if I'm measuring my wind speed in meters per second and my area in meters squared, then I have to use this number. If I'm going to use meters squared as my area and miles per hour, then I need this multiplier. But in our example, we're going to use square feet of area and miles per hour, so we use this. So I created a new acronym called the AVUM. All right, so I use those numbers here. Again, the worksheet gives me the ability to repeat functions and do math very quickly. Over on the left column, I put in the questions, the wind speeds used for questions 5 through 12 here, and I put in my energy pattern factor that I will be using for questions 5, 6, 7, and 8. In questions 9 through 12, I'm going to be multiplying times the number of hours in a year, so I put that in here. And we'll also multiply times 1 kilowatt divided by 1,000 watts. So I added all that in here. So this column is going to be my power density in watts per square foot. This column will be my average annual power density, times my energy pattern factor measured in watts per square feet. And then finally, I will measure my, I will determine my annual energy density by multiplying the power density times the number of hours in a year and 0.001. So this is kind of tricky here. I'm going to teach you a little Excel stuff here. So in this step here, right, I click on the cell and it shows me that I didn't just enter 5.08. Up here in the formula bar, I entered in a formula, right? So if I enter a formula, I start with the equals symbol, equals D $3. So D is the column, and 3 is the row, right? So that value, because I put the $sign in it, that's what's known as an absolute reference. Now I did that because I'm going to want to automate doing the math for these other wind speeds just by using the pull down or repeating function that I'd be using here. All right, so again, we can see that it's the absolute reference of cell D3 times the wind speed of A4 raised to the third power. And when I hit enter, there's my formula. All right. So because I use that absolute reference, when I use the plus sign here, I'm going to be able to pull this down. It's going to do the math for me. Boom, boom, boom. All right. So that's questions 1, 2, 3, and 4. I'm going to remove that. Now when I come over here, and then in this category, or this column, I want to multiply this value, my power density, times my EPF, right? So that number, as I look at the formula, notice I have to use again another absolute reference. In this case, I want to continue using exactly the 1.91 because that didn't change. That did not change. So I'm using H4, which happens to be this 508, times the absolute value contained in E3. It's my energy pattern factor of 1.91. That worked well. Again, I can pull this down to get all my answers. Boom, 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 boom. Didn't like it. Why not? Because those aren't pulled down. So when I pull these back down, the ones next door fill right in. So questions 1, 2, 3, 4, questions 5, 6, 7, 8. Now lastly, we have to enter the values in for my annual energy density, measured in kilowatts per square foot. You can see the formula shown here. Notice it shows the output here, but when I select the formula here, now the cell over here actually tells me that the formula. So we're saying I4, okay, that was the annual power average annual power density times the absolute value of F3, number of hours in a year, and the multiplier to get a kilowatt divided by 1,000 watts. All right, that worked fine. And again, I pull this down and I have all my answers. So there are all the answers I need for this. Now again, the thing that we learned here, this extra thing we learned was this absolute reference, right? This absolute reference $sign. There we go. I want to make that bold. Absolute reference, Command B. So now that's bold. I want to show you what would have happened if that wouldn't have been there. If I come back up here to this formula and I take the $sign out, and I just use D3, and then I pull these back down, watch what happens. They won't calculate because it's looking for whatever's in the cell below D3. There's nothing in D4 or D5 or D6 or so forth. All right. So that's why I need to do it that way. I'm going to undo that. And that's how we do wind power calculations. I'm going to go back to the Word file, and we will look at the wind shear calculation. Quite a few people got number 3 wrong. And number 3, we needed to calculate what the new wind speed would be at 300 feet if the new, which is the new height, if the original wind speed was 10 miles an hour and measured at the original height of 120 feet, taking into account the 0.35 wind shear value. Again, we'll use the calculator to do that. And using the calculator, I'm going to pull this down and we'll look at question number 3. Right? Question number 3 right here. We're going to clear this out. So we have to take and divide the new height by the original height and then raise that to the wind shear value and multiply that times the original wind speed. So 300, 100 divided by 120. There's my answer. But I have to raise that to this wind shear value. So again, I can't use this cubed function. I actually have to raise it. Right? So I have to raise to the 0.35, 0.35, hit equals, and that needs to be multiplied times our 10 miles an hour, times 10 miles an hour. And sure enough, we show that the estimated wind speed at 300 feet is going to be significantly higher than what the wind speed was at 120 feet. I'm going to raise the calculator up a little bit and we'll just show you how to do number 4. In number 4 and number 5, we wanted to calculate what the wind shear value was if I know what my measured heights and wind speeds are. So I'll clear this out. And this one, everyone got this done well, and it would be interesting to find out how many of you divided 11 divided by 12 and then got the logarithmic function. And, oops, I forgot to do something. It's 11 divided by 12 equals. Then I use the log function and divide that by 100 divided by 200. I have to close the parenthesis, get the log, and hit equals. And that was the answer most of us got. Now, if you'd have done it the other way, if you'd have done 12 miles an hour divided by 11 miles an hour, and taken that quotient and got the log function, and then divided that by 200 divided by 100 log function, you come up with the same answer. Doesn't matter which way you do it, just so long as you use the larger ones together and you do it in the same order. All right, so I suppose you want to see how to do that in Excel. That's a great idea. So here we are in Excel numbers, and let me clear that out. Okay, what's going on? Let's go back here. I'm going to clear this data. And I'll clear this data. And I'm going to hide this cell. All right. So, same thing we looked at before. Here's my formula. In this case, I took B3. All right, there's just showing me the formula. So it's going to be B3 right here divided by C3, and all of that is going to be raised. See the raised function? It's going to be raised to F3, the shear factor, times the original wind speed to give me the answer of 16.86. Now in this homework, it's set up for you to just to repeat that for the next two heights. And by using this pull down repeat function, right, just use that repeat function like we saw before, it worked just fine. All right, now I have to unhide row number 6. There's row number 6, and this time I needed to use the logarithmic function. I needed to calculate for the wind shear. So in order to come up with that, notice I put a little helper here. The log ln function is located. You can get that right here. Shows you exactly a good example on how to do this. I'm going to take the log function of the quotient of d6 divided by d8, d6 divided by d8, and that will be divided by the logarithmic function of b6 divided by c6. And there's my answer. And pull that down. And there we go. So it's one way of doing it. You guys probably come up with a few other ways. That's just fine. It's going to be some more math.